So our group discussion is first and second subunit, where we're talking about innovation and design. I hope you enjoy this video from our group. Thank you.
Hello, good morning, amazing people. How are you guys just doing?
I'm good.
I'm glad to hear that. And today is our presentation day. Today is our presentation day. And before we even start it, let's introduce ourselves. Hi, my name is Fatia Leonard.
And my name is Azkara Nusman.
So, as a Gen Z, of course, we have been through a lot of era, and each era is developing some innovation and design. And for today's topic of presentation is about innovation and design. So this is our table of content. So for the first minute, we are going to talk about Eureka, and for the grammar, we are talking about past, present perfect continuous. And the second one is smart wells and past participle phrases. And the last one is laser technology. And the second one is design. We are going to talk about spin-offs, past or present simple passive, with a slightly topic of to infinitive, further, and which. And the second one is specification with the grammar, modals, and semi-modals. And the last one is properties with the grammar, phrases to encourage our participation. So for the first topic of the first minute is Eureka. As in engineering, we all know what Eureka means. And in context of oil and gas drilling, Eureka denotes a moment of sudden, transformative innovation that yields a substantial advancement in drilling practices and operational efficiency. And these are the examples. The first one is seismic imaging, discovered by Robert Malay when he realized that the earthquake damage was caused by moving wave. And then he named it seismic wave. And the second one is slick water for hydraulic fracture. The achievement of good result in 1977 often attributed to the efforts of the Mitchell Energy Company. And the third one is microwave, which was discovered by Percy Spencer in 1945 while working with radar technology, and then he named it rhetoric. And the last one is penicillin. So penicillin is basically an antibiotic discovered by Alexander Fleming in 1928 when he noticed that the mold killing bacteria on a petri dish. And we have some videos to make sure that everyone clear.
Sometimes things don't go according to plan, but every now and then it's for the better. From the microwave to ice cream cones, the accidental inventions on this list completely changed our way of life. Antibiotics. Scottish scientist Alexander Fleming's laboratory was always a mess. Beakers and papers all over the floor, a desk full of petri dishes with different kinds of bacteria. One day, the scientists found mold in one of the petri dishes containing the Staphylococci bacteria. The mold had formed a sterile shield around itself, killing the bacteria in the dish. Fleming, intrigued, decided to further study the properties of this fungus. He received a Nobel Prize for the discovery of penicillin in 1945. Microwave oven. The next time you're heating up a meal or some popcorn in a matter of seconds, don't forget to thank Percy Spencer. Back in his day, microwaves, not the kitchen appliance, but the waves themselves, were used in radar. But one day, Spencer, a Navy radar specialist working for Raytheon, was standing near a microwave-emitting magnetron and noticed that the bar of chocolate in his pocket had turned into a sticky mess. And this is how the microwave oven was invented in 1945.
The next one is the grammar. The grammar that we're going to discuss is present perfect continuous. It's an action that started in the past and still happening now. And for the formula is subject, has or have, depends on the subject. When we using has, we use he, she, or it. And then for have, we use I, you, they, or we. These are the example. The crew has been drilling since dawn. So basically, the crew has drilled and are going to continue and still going to continue even after the dawn. And this is for the video.
Present perfect progressive. Present perfect progressive is a verb tense. We use the present perfect progressive tense for actions that started in the past, continue to the present, and will continue in the future. For example, I have been working at this company for 8 years. I have been living in France since 2015. I have been watching TV for 3 hours. The present perfect progressive is formed with have, been, and the ing form of the main verb. How do we get this verb form? First, the present perfect is formed with the verb have, plus a past participle form. Next, a progressive verb is formed with be plus an ing verb. The past participle form of be is been. When we put it all together, we get the present perfect progressive form of have plus been plus an ing verb. Have changes forms depending on the subject. You have been learning English for 8 years. She has been sleeping all day. Snow has been falling all night.
Hope we're clear on that. And who wants to be a volunteer to read the dialogue with me? Okay. You'll be Fatia and I'll be Fatia, okay?
We've been analyzing the downhole earlier times for weeks, and I think we've finally uncovered a game-changing pattern.
I can review your data, and it really looks like this breakthrough could optimize our entire drill sequence.
We've been testing the new adjustment model since yesterday, and the rate of penetration has increased sharply.
That's impressive. Our team has been waiting for a discovery like this to enhance efficiency across the operation. Yes, ma'am. And for the next topic is smart wells. So basically, smart wells are advanced sensor-integrated systems that enable real-time remote control of downhole conditions to optimize drilling performance and reservoir management. So these are the examples. So for the first one is multilateral snake well in oil reservoir. It's an advanced solution designed to maximize efficiency and recovery from geological formation by combining reservoir exposure with intelligent flow control capabilities. And the next one is remote control coil tubbing snake well. Is to reel the tapping to the maximum depth, overcoming friction and buckling limitation. And the last one is automated rotary steerable signal system. Is to drill complex and winding well paths. This is the video.
At Chevron, our experts use horizontal drilling to drill down thousands of feet before turning the bit horizontally to drill out thousands of feet in the targeted production zone. This approach efficiently recovers more resources with a smaller environmental footprint than drilling multiple vertical wells. According to the Energy Information Administration, horizontal drilling has been used across the industry intermittently since the 1920s and became commercially viable in the 1980s. Enabled by steerable tools, horizontal drilling provides our teams with better access to areas of reservoirs, thereby increasing production. More recently, directional drilling has been pushed further with great results. Directional and extended reach drilling have allowed operators to access reservoirs far from the drilling location.
I hope everyone's clear on that. And for the next grammar we're talking about is past participle phrases. So past participle phrases is an adjective headed by past participles. So this is the example of past participle. This is the automated valves have been installed, creating a streamlined remote control system for the smart well. So as we can see here, after they have been, so we can see here, this is passive, it's a passive voice, and after the comma we have gerund as a noun. This is the video.
Hey guys, I'm Carrie. In this video, you'll be learning about participial phrases. What are participial phrases? Participial phrase is a word group that has a participle along with any words that modify it or complete its meaning. For example, climbing the tree, the monkey disappeared into the branches. Climbing the tree is the participial phrase in this sentence. Another example. Speaking eloquently, Mr. Bond enthralled the audience. Speaking eloquently, the participial phrase in this sentence modifies the noun Mr. Bond. The adverb eloquently modifies the present participle speaking. Another example. Jason Jones, sometimes known as J-Jo, held the U.S. national record for the men's 100-meter hurdle. The participial phrase, sometimes known as J-Jo, modifies the noun Jason Jones. The adverb sometimes modifies the past participle known. Also, the adverb phrase as J-Jo modifies known. Voted back into office, the mayor thanked his supporters. The participial phrase, voted back into office, modifies the noun mayor. The adverb back and the adverb phrase into office modify the past participle voted.
And who wants to dialogue with me? Okay. You'll be Zara and I'll be Fatima. Is that okay?
Okay. The news article fell have been excelled, and therefore the flow rate is now easier to regulate pressure.
Yes, the pressure sensors we calibrated last time, which means we can detect anomalies instantly.
All the data has been transmitted to the control unit, and as a result, the controlling process is far more efficient.
Automated settings have been updated, so the system can adjust itself without manual intervention. Thank you. And then we moved on our last topics of this unit is about laser technology. So laser technology is the use of device that produces a highly focused and coherent beam of light through a process called light amplification by stimulated emission of radiation, aka laser. So these are the examples. For the first one is liquid laser. So liquid laser has a function to generate nebular light over a broad range of wavelengths. And for the usage is to tattoo and birthmark removals. And the second one is isotope separation. And the last one is photodynamic therapy. The second one is solid-state laser. So, solid-state laser has a function is to generate a powerful, precise, and narrowly focused light beam for a high performance applications. And the usage is for surgery and dermatology. The second one is cutting, welding, and engraving for manufacturing, and the last one is remote sensing. And the last one is semiconductor laser. So it has a function is to convert electric current into a light beam, into a focused light beam. So for the usage is for laser surgery, and then imaging and diagnostic, and the last one is it can be used in printers and scanners. For the video, this is the video.
Laser lights are everywhere, from barcode scanners to cutting thick metal pieces for automobiles. We have also used lasers at least once in our lifetime, even if it was not as powerful to cut through metal. But how does the laser work? How do we get that straight beam of light? In this video, we are going to learn about the laser and how it works, how is it that powerful to cut through metal, and how we get that straight beam of powerful light moving in a single particular direction. Simply, a photon is bounced back and forth between two mirrors until it becomes a beam of light, and it is then released from one end, which we see as the laser light. But how the first photon is achieved, and how can a photon become powerful just by bouncing it back and forth? We will learn some amazing things in this video, so let's get started. This is what we will start from. We have a flash tube which will give us the first photon, a crystal rod, two mirrors, one 100% reflective and another 95% reflective, a power supply, and finally a switch. When we press the switch, the power supply provides power to the flash lamp and it lights up. When the lamp lights up, it releases photon particles. Those photon particles are absorbed by the electrons present in optical materials like glass, crystal, etc. When the electron absorbs the photon, it gets into an excited state or stimulated form and jumps from one level to another level, but it cannot maintain that state, so it jumps back to the previous level known as the ground state. When the electron jumps to the ground state, it releases a photon particle. But if the electron is already in an excited state and gains energy, then it will release two photon particles when deducing to the ground state. That one photon particle is doubled again and again or amplified. Then the photon particles that are exactly perpendicular to the mirrors are bounced between two mirrors, and when bouncing between mirrors they encounter even more electrons, and the same process of receiving energy and doubling the photon takes place again. When there are enough photon particles, they penetrate from the mirror, which is less reflective, and that is what we see as the beam of light. As the photon exactly perpendicular to the mirror is bouncing, that's why we get a straight beam having only one direction. The number of photons released from the beam will be directly proportional to the power of the laser. If we are somehow able to use every single photon produced in a laser light, it will be the most powerful laser. Of course, that is not the only thing that affects the power of laser, there are many things.
And the next presentation will be held on Zahra.
Before next the topic of spin-off, I will introduce myself. My name is Azhara, and I will presentation about spin-off. So, spin-off are technologies initially developed for space research that are subsequently adapted for whether commercial or industrial application. For the example, UV protective material used to protect astronaut eyes and skin from UV rays. And the next, robot climber control algorithm to control satellite movement. And 3. Explosive detection devices used to discuss spacecraft launcher. And we have video.
Hi, I'm NASA Administrator Charlie Bolden. Ever since NASA's founding in 1958, the technologies that we've developed to power space exploration have also found a home right here on Earth. In fact, it's part of NASA's mission to ensure that the results of our research and development go on to benefit all of society. Technology spin-offs are made possible by the unique partnerships forged between NASA and people like you. To date, our technology transfer programs have helped to create more than 1,800 spin-offs, touching on nearly every aspect of our lives, from life-saving medical devices to the food you eat. Each year, NASA's spin-off publication highlights the best examples of these technologies. My favorites in this year's book include a satellite tracking system that has saved 30,000 lives worldwide, a surface coating for buildings that eliminates air pollution, and hospital robots programmed to help care for patients. Spin-offs represent the practical, down-to-earth benefits of our space investments. As we look to NASA's future in exploration and the technology required to get us there, it's clear that there is much, much more to do. There's more space in your life than you think. To learn more, visit us at spinoff.nasa.gov.
And the next thing is grammar, present, past simple. So, grammar, present, past simple structure is always be and forte or past participle. For the present simple passive is used am, is are. For the past simple passive, use was or were. And we have to infinitive for doing and which. To infinitive, the structure is to plus base form of the first one. For doing, the structure is for plus base verb plus gerund. For which is extra detail. And the example, this member form is used in verbs to improve. Here is used mean present simple passive. Example 2, the sensor was developed for detecting. The mean was developed is a simple passive. Example 3, water filters are produced to purify water. The means are produced is a simple passive. And we have a video for grammar, present or past simple passive.
Present and past passive.
I speak English.
Most English sentences are active. In active sentences, we are more interested in the person or thing which is doing the action.
English is spoken all over the world.
We use the passive when we are more interested in the action, or when we don't know who or what does the action.
William Shakespeare wrote Hamlet. Hamlet was written by William Shakespeare.
We can also use the passive in the past. We use by with the passive to say who does the action. We form positive present passive sentences like this. We use be in the present tense with the past participle. We form negative present passive sentences like this. We form questions and short answers in the present passive like this. We form the past passive like this. We form the negative in past passive sentences like this. We form questions and short answers in the past passive like this.
And the next dialogue with and will be facilitated, okay? Mnemonic form is used in medical questions to improve patient comfort with how specific benefit daily life.
Yes, it was developed by NASA for absorbing during spacecraft landings.
Water purification filters are purposed to prevent clean drinking water in remote areas.
And then insulation materials was created for spacecraft, which later became standard in energy efficient buildings.
Thank you. And the next topic is specification. Specification is the detailed document that defines the exact requirement, constraint, and standard for a mechanical system, component, or product. The example of specification, like a web browser, a computer operating system, and a transport system. And now we have a video about specification.
Growing intelligent transportation system and how our tax dollars can transport us into a safer and even more money-saving, tax-saving, and connected future. We see the intersection of Pineda Causeway and Wickham Road. Let's look at our already deployed closed-circuit television, known as CCTV, and vehicle detection sensors working alongside the high-speed network beneath our feet, and then add in the future possibilities. There's more to our intelligent transportation system than meets the eye, as CCTV allows traffic management staff to get a real-time look at traffic flow and watch for accidents. Vehicle detection, with its special sensors, automatically detects the presence of vehicles and obstructions on the roadway and instantly warns the management center. Meanwhile, our already on the way crosswalk detection software will use similar vehicle detection sensors to check for people in the crosswalk and warn oncoming traffic day or night and in all weather conditions. Now, let's add in some other existing possibilities like Bluetooth technology. which can detect the speed of vehicles entering and exiting the roadway. The Traffic Management Center now not only sees the intersection, but has much deeper traffic flow data to use for safety and roadway improvements.
The next is grammar modal and semi-modal. Modal and semi-modal verb is an auxiliary verb that express ability, possibility, permission, or obligation. And the semi-modal type is the word is to, like have to, need to, ought to, used to, and dare to. The modal type is can, could, is the type ability, for permission, can, could, may, the type advice, should, obligation, must, have to, possibility, might, could, and may. Next, we have a video.
A modal verb is a type of helping verb that is used to express ability, possibility, permission or obligation. Let's see a few examples. Can and could are used to show ability or lack of ability.
Sprichst du Deutsch?
Laura can't speak German. Can and could are also used to ask or give permission.
Excuse me, could I use your bathroom?
She is asking for permission to use the bathroom. Can and could are also used to make offers or requests.
Excuse me, could you help me?
The lady is making a request. Should is used to give advice.
I have a terrible headache.
You shouldn't have drunk so much wine last night.
I should take an aspirin.
Must is used to express necessity or obligation. Drivers must always stop at the red light. May is used to ask or give formal permission, request or assistance.
Hello, I am Bridget. How may I assist you?
Bridget works at the customer support of a company. She is talking to an unknown person, so she has to be professional and formal. Have to is used to express necessity or lack of necessity, or to persuade.
You have to try this dish. It's so delicious.
Aditi is trying to persuade her friend Albert to try her dish.
I have dialogue and one of I am Alexandra and I will be presenting. We must update the torque limit in the specification on component could fail under high load.
I agree. We should include a higher safety factor since the design may face variable stresses.
The actuator also be reinforced to meet the new performance criteria.
Yes, and the housing dimensions have to remind phrases to ensure proper alignment.
Thank you. And this is the topic about properties. Properties in synthetic textile and composition are their engineered physical and chemical traits that determine performance in both geotextile application. The example, fire resistance, thermal protection, and durability. And we have a video.
Engineered with Teflon and reinforced fiberglass, PTFE structural membrane set the gold standard in durability and performance, offering unmatched resistance to UV exposure, chemicals, and extreme weather. It boasts an impressive lifespan of over 25 years. As the most fire-resistant option in the industry, PTFE membrane is the preferred choice for iconic, long-lasting tensile structures. With its smooth surface and lotus leaf effect, PTFE keeps structures clean with minimal maintenance. It transforms sunlight into a soft glow with 8 to 25% light transmittance. It provides day lighting while blocking excess heat. Our processing facilities are equipped with 3.8 meter wide CAD-assisted automatic cutting tables and welding machines, staffed by experienced professionals in PTFE membrane fabrication. We offer a complete, one-stop solution for end users, encompassing all aspects from size measurement, material production to engineering design, fabric cutting, welding, assembly, packaging, logistics, and on-site installation. We have extensive project experience to custom design solutions. Contact us today to discuss your project requirements.
Is that grammar? We're looking for phrases to encourage participants. Phrases to encourage participants is designed to invite others to contribute ideas, their opinions, or engage actively in a discussion. Like asking for opinion. Use phrases like, what's your opinion about? And the next, asking for explanation. Use phrases like, could you explain to me? When it's your turn to speak, you should quickly mark your opinion and start with, in my opinion. Example, like when someone is already doing well, like we say, there we go. When someone is having a trouble, we say, hang in there, don't give up. And we have a video about phrases to encourage participants.
Okay, we are way too fun.
All right, what you got? Bring it on. Give me your best.
Carla,
yes.
People have come to your small group. How do you encourage participation? People speaking.
Yeah, that's a fine question because again, you got people sitting around awkwardly staring at each other, right?
Yeah.
I have a friend, my friend Tom invented this thing, and I love this. This is a great like kind of icebreaker where Tom would be like, tell me something that's on your playlist that would surprise me. Right?
Oh,
yeah, or like what's the last movie you saw that you hated? Or what have you been binge watching? Like just something that gives you
questions.
Yeah, but even just to do those kind of one-on-one and not necessarily everybody in the group has to share whatever, but just like encourage, hey, turn to the person next to you and here's your question. Take 3 minutes to talk about that.
Yeah.
And then even after that, be like, okay, what did you hear? Or whatever. Like, getting people to share that stuff, it just takes everybody's mood down into kind of more of a relaxed place. And it just kind of breaks tension. Because I think a lot of times in small groups, it feels like we're here to have a serious conversation.
We're going to go super deep, super
We have
quick.
45 minutes to do so.
Yeah.
Yeah, and it just feels so structured where really the whole idea of a small group is for it to be relational. And for like you might not get through the thing you were going to get through.
Right.
But if you're building community and feeling like you're connecting with these people and like, no, my life is richer because we now know each other better.
Wow.
That's a successful small group, Julia.
The connection.
Yeah.
The connection
So
with
that's how you
people.
get people to participate. You make it feel like a community.
Yeah.
Yeah.
I love it.
Thanks.
That was a great tip from Carla.
I will be Zara and you will be my guest. Okay. Feel free to share in too, especially on how the tensile strength of these geotextiles support the load distribution.
Sure, and don't hesitate to add anything because its permeability also playing a crucial role in drainage control.
Go ahead and comment on the durability text. The UV resistance seems to outperform the previous material.
Absolutely, and please jump in if you notice more, since the chemical stability could influence long-term performance.
Well, thank you. Next. Do you have any questions?
So, is there any of you wants to have a question? Okay.
My name is Molly Eureka, so I
What technical challenge commonly occurs when small-scale sensors transmit real-time pressure data to the control center?
That's a great question. Is there anybody else who wants to ask?
Is the focus of the sentence from the plot of the extension to the receiver, and what is the basic formula used to form this structure?
Thank you, Marcella, for the question. And is there anybody else?
My name is Abizaki. Any question? How does the present perfect continuous differ from the present perfect simple in terms of focus and use? Especially when describe action that's covered in the past and continuous to the present. Thank you.
Okay, thank you for the question.
Okay, I will be answering the question of factor. The answer that academic signal device or signal was due to downhole environmental condition. Is that clear? Thank you.
Okay, for the second question, we have Marcella's question. And for the answer is the present perfect continuous focus on duration or ongoing nature, while the present perfect simple is focused on the completion or result of the action. Are you clear on that? And the last one is from Hafiz. The answer is the present simple passive shift the focus to the receiver of the action, while the doer is a noun, unimportant or just. Are we clear on that? So this is the end of our presentation, and I'm so sorry for the technical issues and human error. I hope you guys are enjoying our presentation, and